Welcome to chapter 7.5, Combustion Reactions. We're back to this awesome photo of this huge explosion because that's what we're talking about today. Exothermic reactions. Reactions that create a lot of heat and are awfully fun and do some pretty amazing things. Combustion comes from a Latin word I'm not going to attempt to pronounce, but it just basically means to burn. Okay, so that's what we're going to be looking at today, is a whole variety of combustion reactions. Let's go on with it. Right, the first one is natural gas, mostly methane. In this example, the methane natural gas is being burnt off and creating the heat that you cook your soup with. Okay, now you know with your oven that it takes just a little bit of a light to set it off, alright, a little bit of a spark, and then it'll burn quite well from there. So there's a starting condition for methane. You set it off, and then it'll start burning from there on. Now it does require the presence of oxygen. Okay, so if you throw a fire blanket over the top, it'll go out. Okay, you'll still have methane, pouring out of your oven, but if you don't have it, if you deny it oxygen, the fire will go out. The reactants of this reaction are carbon dioxide and water. So you will see some water coming out, but mostly it's as steam, and you wouldn't even notice it in the majority. So natural gas, combustion reaction. A liquid octane. Okay, most are commonly in fuel for cars. Octane, in the presence of oxygen. A lot of these engines, they actually spray the petrol into a gas-filled chamber, into an oxygen-filled chamber. They need to spray it to make sure that there's a good distribution of octane to oxygen, so that when it's ignited, with a spark plug, we get this carbon dioxide and water that we saw before. And the carbon dioxide is assuming that we have enough oxygen. Okay. Now, some engines aren't working very well, or don't get enough oxygen into them. We end up with carbon monoxide. If we only have one oxygen here and not enough oxygen to complete this reaction, instead of getting carbon dioxide, we get carbon monoxide, and that is a bit more dangerous for us. But this is another example of a combustion reaction. Petrol in cars. Next, kerosene. Believe it or not, jet fuel. So this jet goes to Mach 3 or whatever it gets to, and it does so by burning kerosene, again in the presence of oxygen. Okay, you're going to see a pattern here about this little component of oxygen. Kerosene in the presence of oxygen, set it off, give it a bit of an ignition, and it'll burn, create a lot of energy that allows the plane to go, or the jet to go where it needs to go. Carbon dioxide and water are the products to this reaction. Again, if it's not burning properly, you do get carbon monoxide as a result. Power stations. Coal, burnt in the presence of oxygen. Carbon dioxide and water. Same kind of thing. A lot of this is steam. Okay. Now, as we discussed in the last video, there are a lot of other byproducts to this. It's not only steam. We do tend to get some hydrochloric acid coming off it. But as we discussed, they do some scrubbing nowadays that should make sure there's not too much in there, but it is awfully polluting. Especially if we don't have enough oxygen, if we haven't pumped enough oxygen into the coal to allow this reaction to move to completion to carbon dioxide, we do get carbon monoxide. And carbon monoxide, as we keep on saying, is a much more dangerous gas than carbon dioxide. Kittens. Glucose plus oxygen, carbon dioxide and water. Do we recognize this? Cellular respiration, of course we do, because we loved it. So glucose burning in the presence of oxygen, okay, carbon dioxide and water. And again, the same kind of thing. Remember I said that if the respiratory system doesn't work properly and you don't get enough oxygen, or if you're anaerobically running, yeah? So if you're running and you're sprinting and you're going flat out, you can't get enough oxygen into your cells. So the glucose doesn't burn properly, and you end up with lactic acid. Burning, and poor old kittens get stitches and things like that, and that's why the kitten is so cute. Lastly, we end where we begin. Hydrogen plus oxygen forming water. Now I said that, you know, it can result in quite a lot of energy, and hydrogen fuel is an amazing fuel. Okay, it's what we use to send spacecraft into space. This is just hydrogen burning in the presence of oxygen, creating steam and an awful lot of fire, and that allows us to burst off into space. Okay, now the common reaction here, or the common reactant, is oxygen, and a lot of combustion reactions are actually called oxidation reactions. Now, unfortunately, it gets a bit more complicated there, and in Year 10, in chemistry in Year 10, we're going to talk about this a bit more, but oxidation reactions don't always involve oxygen. But at this point, just be aware of oxidation reactions, okay? Combustion reactions are an example of oxidation reactions. They use oxygen in a way that allows them to create the awesome power that we see in jet fuels and kittens and spacecraft. Thank you. So this is basically the end of Chapter 7. What I want you to do now is I want you to go to the Chapter 7.5, pick out the blue words, and put them into Quizlet. Keep practicing, good luck, and I'm sure we'll be having a test on it soon. I'll see you in class. Bye.